The light that hits your eyes right now. At this very second, as you listen to these words, light that left the surface of our sun 8 minutes ago is slamming into your eyes at a speed of nearly 300,000 kilometers per second. Yes, you heard that right. 300,000 kilometers in a single second. This is the absolute maximum speed that exists anywhere in the universe. Always, everywhere, without exception. And if, by some miracle or other means, you could reach this speed, the speed of light itself, time would stop completely for you. Totally. You would cease to exist in the way we normally understand existence. Your body would compress into an infinitely thin disk, and the entire infinite universe, with all its galaxies, stars, planets, worlds, and civilizations, would instantly collapse into a single, blindingly bright point hanging right before your face, like a final glimpse of reality before vanishing. And this is not fiction, not fantasy, not a sci-fi movie plot. This is pure, rigorously tested physics, confirmed by hundreds of experiments repeated in laboratories around the world for more than a century. And today, in the next few minutes, we will dive into the very heart of this madness, into that exact point where common sense shatters and reality reveals its true, unimaginable face. We will explore together three greatest paradoxes, three deepest mysteries that inevitably await any traveler daring to approach the speed of light, even by a tiny fraction of a percent. The first paradox is what you will see with your own eyes when your ship begins to accelerate to near light speeds. And believe me, it will be nothing like what you're used to seeing in Star Wars, Star Trek, or any other film. There will be no beautiful streaks of stars, no thrilling flight through galactic nebulae. Reality will be far stranger. The second paradox concerns the very nature of time, how it begins to twist, slow down, almost stop, and behave in the most unpredictable ways as you approach this light speed barrier. But the third paradox is perhaps the heaviest of all. It calls into question your very self, your existence as an individual, as part of humanity, as a being connected to past, present, and future. You will learn something so profound it might keep you awake tonight, or, on the contrary, plunge you into the deepest, most elevated contemplation about the nature of being, time, space, and what it means to be human in an infinite cosmos. If these mysteries truly fascinate you, if you feel the universe whispering its secrets to you through the fabric of space and time, don't forget to subscribe to this channel, because our journey into the deepest layers of reality begins right now. Let's start with what we were taught in school. Remember those physics lessons where light was described as something simple and understandable? It travels in straight lines. It has a fixed speed. It's an electromagnetic wave. Everything seemed logical and orderly. We were shown pictures, spaceships speeding past stars, which turned into beautiful glowing streaks stretching along the sides of the screen. We saw this in dozens of movies. It seemed that all we needed was a powerful enough engine, and the galaxy would open up before us like a vast map, ready to be explored anywhere we wished. That image was comforting. It gave us hope that humanity would one day conquer space, just as we once conquered the oceans. But reality, my friend, is far stranger, far terrifying, and far more awe-inspiring than any Hollywood fantasy.
Everything changed in 1905 when a 26-year-old patent clerk in Switzerland, Albert Einstein, published a paper that turned our understanding of the universe upside down. His special theory of relativity proposed something unthinkable. The speed of light is the same for all observers, no matter how fast they are moving. It sounds innocent, but the consequences of this statement shatter everything we took for granted about space, time, and the very nature of reality. Imagine, you're standing on a platform and a train speeds past you at 100 kilometers per hour. A passenger throws a ball forward at 20 kilometers per hour relative to the carriage. To you, the ball flies at 120 kilometers per hour. This is ordinary velocity addition. But what if, instead of a ball, he turns on a flashlight? Logic suggests the light should travel at 300,000 kilometers per second plus 100 kilometers per hour. But no, the light still moves at exactly 300,000 kilometers per second, no more, no less, for any observer anywhere in the universe. This seems absurd, but countless experiments confirm this is how our universe is built. And for this to work, the very fabric of space and time must bend, stretch, and compress in the most curious ways. Reality turned out to be even stranger than Einstein himself might have imagined. When physicists began to deeply study the mathematics of relativity, they encountered consequences bordering on the supernatural. The first is time dilation. The faster you move, the slower time flows for you compared to a stationary observer. This is not a metaphor. It is a physical reality confirmed by experiments with atomic clocks on airplanes and satellites. The difference is tiny at everyday speeds, but it is absolutely real and measurable. Now imagine what happens at speeds approaching the speed of light. At 90% C, time flows 2 times slower. At 99% C, 7 times slower. At 99.9% C, more than 20 times slower. And at speeds differing from light speed by only millionths of a percent, time practically stops. What does this mean in practice? You board a hypothetical spaceship and accelerate to 99% the speed of light. Your destination is a star 50 light-years from Earth. According to your clock, the trip there takes about 7 years. You turn around and fly back. Total, 14 years. You've aged a decade and a half. But when you step out of the ship, you discover that over 100 years have passed on Earth. Everyone you knew is long dead. The world has changed beyond recognition. You've become a time traveler, but only in one direction, into the future, with no way back. This is the first horror of near-light speed travel. You don't just move through space, you fall out of your own era. Every journey is a farewell to everything you knew and loved, and the faster you fly, the farther into the future you are thrown. But time dilation is only the beginning of the strangeness. The second consequence of relativity is length contraction. When an object moves at high speed, it physically shortens in the direction of motion. At 50% C, contraction is about 13%. At 90% C, more than 2 times shorter. At speeds close to light speed, the object becomes practically flat, like a sheet of paper facing you edge on. This means that for a traveler on a near light speed ship, all space contracts in the direction of motion. The distance to a distant star, 50 light-years from an Earth observer, becomes much shorter for the traveler. This is not an illusion, it's a real change in the geometry of space from the traveler's perspective. The universe literally collapses before you as you race through it.
Now, the main question, what would you actually see with your eyes if you accelerated to a significant fraction of light speed? Forget everything shown in science fiction. Reality will be completely different. The first thing you'd notice is that stars begin to shift forward. This phenomenon is called relativistic aberration of light. Imagine running in the rain. Even if raindrops fall vertically, they seem to hit your face at an angle. The same thing happens with starlight at high speed. Light that should come from the side or behind now appears to come from the front. The faster you go, the stronger the effect. At 50% C, most stars are already in your forward hemisphere. At 90% C, nearly all stars gather into a narrowing cone ahead of you. At 99% C, the cone shrinks to a tiny disk. And at speeds even closer to light speed, the entire visible universe, all stars, galaxies, all light, collapses into a single blinding point right before your eyes. This is not poetic metaphor, it is a mathematically inevitable consequence of relativity. But aberration is only half the visual madness. The other half is the relativistic Doppler effect. You know how a siren's pitch changes as a car approaches or recedes? The same thing happens with light. Instead of pitch, it's color that changes. When you move toward a light source, visible light shifts into ultraviolet, ultraviolet into X-rays, X-rays into gamma rays. This is blue shift. When you move away, light becomes redder, then infrared, microwave, radio waves, and vanishes from sight. Now combine both effects. You're flying at near light speed. All stars have gathered into a point ahead due to aberration, and their light undergoes extreme blue shift. Ordinary stars now bombard you with deadly X-rays and gamma radiation. And behind you, absolute darkness, blacker than any night on Earth. The traveler would witness an apocalyptic scene. Ahead, a blinding ring of light, growing ever brighter and deadlier. Behind, an absolute abyss of darkness. And this image becomes more extreme with every added percent of speed. Physicists have created computer simulations of what a traveler would see. The results are astonishing and terrifying. At 70% C, constellations are already unrecognizable. Orion, Ursa Major, the Southern Cross, distorted beyond recognition. At 90% C, the sky splits into two zones. Ahead, a bright bluish glow. Behind, expanding darkness. At 99.9% C, the forward zone shrinks to a narrow disk. Red giants appear blue. Yellow stars, like our sun, shift into X-rays, but their place is taken by previously invisible infrared objects. This creates a new problem. Even if you have a ship and radiation shielding, how do you navigate? All familiar reference points are gone. The sky has become alien, unlike anything you've ever known. And here's the strangest part. Length contraction applies not just to you, it affects everything you fly past. Fly by Jupiter at 90% C, it appears as a flattened disk. At 99.9% C, Jupiter looks like a thin pancake. At even higher speeds, like a barely visible streak. The same goes for galaxies, planets, nebulae. The entire universe compresses before you, as if someone grabbed reality by the edges and pulled it toward your gaze. Space, once seeming infinite, becomes strangely compact. Distances of light years shrink to sizes traversable within a single human lifetime, according to your clock, of course. For those left behind, centuries and millennia will pass. Now let's talk about what happens when you try to reach exactly 100% of light speed. The math begins to scream. According to relativity, an object's mass increases as it approaches light speed. This is relativistic mass, a measure of the energy needed for further acceleration. At 90% C, mass is 2.3 times greater than rest mass. At 99.9% C, 7 times greater. At 99.99% C, 22 times, and so on, toward infinity. What does this mean? To accelerate an object to the speed of light itself, you would need infinite energy. All the energy from all the stars in the entire observable universe could not accelerate even a single speck of dust to light speed. This is an asymptotic limit, a fundamental law of nature, as unbreakable as the conservation of energy. Only massless particles, photons, gluons, and possibly gravitons can travel at light speed, and they must do so. No faster, no slower. And here arises a paradox that makes your head spin. What happens to time for a photon? At light speed, time stops completely. This means, for a photon, time does not exist at all. From the photon's perspective, the moment it's emitted by a distant star and the moment it hits your retina are the same instant. For it, no time has passed, even though billions of years may have elapsed for us. Length contraction also reaches its limit. The distance between source and destination is zero. The photon does not travel through space. It simply exists in a strange, timeless state that we, slow beings of flesh and bone, interpret as motion at 300,000 kilometers per second. Why exactly 300,000 kilometers per second? We live in a world where the fabric of reality behaves differently depending on speed. Time is not a constant, but a variable. Space compresses and stretches. Simultaneity, length, and duration become relative. And science still cannot explain why the speed of light is this absolute limit. We know that it's so, we can describe the consequences, but why 300,000 kilometers per second? Why not a million, a billion? This is one of the fundamental questions for which we have no answer. We accept it as an axiom, the foundation of all our understanding of the universe. Now, what would actually happen to your body if you were aboard a near-light-speed ship? The visual effects are just the tip of the iceberg. The physical consequences are far harsher. 1. Acceleration. To reach 90% c at a comfortable 1g acceleration, like Earth's gravity, you'd need 9 months of continuous thrust, which is biologically possible, but where do you get the fuel? 2. Fuel. The most efficient option is antimatter. Annihilation releases 100% of mass energy, E equals mc squared. But even then, to accelerate a 1,000-ton ship to 90% C, you'd need as much antimatter as the ship weighs. To decelerate, you'd need just as much again. Total, 3 to 4 ship masses in pure antimatter. Humanity has produced a few nanograms of antimatter in its entire history. At current rates, it would take trillions of years to gather enough for one trip. 3. Interstellar dust, like bullets. 1 hydrogen atom per cubic centimeter, almost a vacuum, but at 99% C, each atom becomes a bullet with energy comparable to a pistol round. Billions of these bullets per second equals a storm of microscopic nuclear explosions on your hull. Even the strongest shield would be punched through on a long journey.
And all this is just physics. Imagine yourself in a sealed ship hurtling through the void. Outside, absolute darkness behind, a blinding ring of radiation ahead. Stars are not stars. Space is not space. You're flying to a star just a few light years away. A few years pass for you, but you know for sure, when you return, everyone you loved will be long dead, not just old, buried, forgotten. Civilization will have changed beyond recognition. You'll become a ghost from the past, a stranger in a future world. How can the human mind cope with this? Our brains did not evolve for such scales of time and distance. This is existential terror, and we have no psychological defense against it. What if you try to exceed light speed? Physicists have considered hypothetical particles, tachyons, that always travel faster than light. Ordinary particles can't reach C. Tachyons can't slow down to C. But their existence would violate causality. At superluminal speeds, time begins to run backward. A tachyon from point A to B could arrive before it left. This means it's sending information into the past, creating time paradoxes. Most physicists believe tachyons do not exist because the universe is built to protect cause and effect relationships. The speed of light is a reality barrier, not just a speed limit. There are other theoretical paths, wormholes, Einstein-Rosen bridges. Imagine space as a sheet of paper. Fold it and punch a hole between 2 points. You travel millimeters but end up on the other side of the sheet. General relativity allows such structures, but natural wormholes are microscopic and unstable. To make them traversable, you need exotic matter with negative energy, which may not exist. We don't know where the exit leads, maybe into a black hole or a star. We don't even know if they're possible in principle. In 1994, Miguel Alcubierre proposed an idea. Don't move the ship through space, move space itself around the ship. The ship sits in a warp bubble, while space contracts ahead and expands behind, creating a wave. The bubble can move faster than light without violating relativity. Inside, everything moves slower than C. But the problems? It requires exotic matter, originally energy equal to the mass of the entire universe. Later estimates, Jupiter's mass, still impossible. No control, you're cut off from your own future, can't stop or steer. Upon stopping, all accumulated energy is released forward, sterilizing an entire planetary system. Your engine becomes a weapon of mass destruction you can't turn off. Any faster than light travel violates causality. If you can arrive before you depart, from some observers' view, you create time paradoxes. Many physicists believe the universe is structured so that FTL travel is fundamentally impossible, not due to technology, but laws of physics. Light speed is a limit of reality itself. Part 20. The Philosophy of Time. What is now? Near-light travel raises deep philosophical questions. If you return after 14 of your years, but 100 years pass on Earth, who are you? You're a relic of the past, a living fossil, a stranger in a world that moved on without you. Relativity shatters the illusion of a universal now. Time becomes personal, subjective. But what is time really? A fundamental property of the universe, or an illusion of consciousness? Why does it only flow forward? What makes the present special? Science still has no complete answer. Einstein wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." According to eternalism, the entire history of the universe, past, present, and future, exists as a single four-dimensional block. We merely illuminate different slices of it with our consciousness, like a flashlight beam in a dark room. Your birth and death are equally real right now. Dinosaurs still roam Earth in their own layer of space-time. Beings in the far future already live, though we haven't been born yet. Near-light travel doesn't move you through time, it changes the angle at which you cross the block universe. Now, the big picture. The nearest star, Proxima Centauri, is 4.2 light-years away. With current technology, the trip takes 70,000 years, longer than all of human civilization, and there are trillions of galaxies. Light speed on cosmic scales is a snail's pace. Physicists call this cosmic quarantine. Intelligent civilizations, if they exist, are forever isolated by distances impossible to cross within the lifespan of any civilization. This is one explanation for the Fermi paradox. Where is everybody? We are islands in an ocean of void, shouting into the dark, but never hearing a reply. The expanding universe and the cosmological horizon. But it gets darker. The universe is expanding with acceleration due to dark energy, 68% of all energy. Because of this, distant galaxies are receding faster than light speed. This doesn't violate relativity, it's space itself stretching, not objects moving through space. Result, there are galaxies whose light will never reach us. They lie beyond the cosmological event horizon. In trillions of years, nearly all galaxies will vanish from view. Only our local group will remain. Intelligent beings of that era will never know the universe once held trillions of galaxies. That history will be lost forever.
And beyond that, only darkness. Stars will burn out. Black holes will evaporate, Hawking radiation. In 10 to the 100, the universe will become an infinite, cold, empty void, the heat death. No life, no light, no structure. Eternal, unchanging emptiness. Yes, we cannot reach light speed. Yes, the cosmos is vast and inaccessible. Yes, everything will end in darkness. But here, now, we are alive. We are aware. We ask questions. This is the greatest miracle. We are the universe becoming conscious of itself. Every photon in your eyes is a message from the past. You are literally looking into the past. The moon, 1 second ago. The sun, 8 minutes ago. Stars, thousands of years ago. Galaxies, billions of years ago. You are a cosmic traveler. You always have been. Earth carries you around the sun, 30 kilometers per second. The sun orbits the galaxy, 230 kilometers per second. The galaxy flies through space, 600 kilometers per second. The speed of light is a boundary of our cell, but also a window. We won't conquer the cosmos, but we can understand it, contemplate it, accept it. Because sometimes the longest journeys are made in the silence of closed eyes.